Okay, so we're solving with assigned chapter 2, problem 8, which is 36 from Giancoli 6th edition. So we have a baseball. So this baseball is hit nearly straight up into the air. So the baseball is down here and it's hit up with a certain initial speed. This initial speed is 40 meters per second. And the first question is, how high does it go? Okay, to solve the problem, I should choose a reference frame. And I'll choose as reference frame this straight line going up. Okay? So this tells me the motions going up are going the positive direction. Alright, so this means that this initial speed is plus 40 meters per second. And gravity is there, always pointing down, always pointing towards Earth. So gravity, according to this reference frame, will be minus. Gravity is going opposite to my reference frame, so minus 9.8 meters per second squared. All right, the question is, how high does it go? We know that this baseball keeps moving until it stops. Okay, so how high means how far up does it go until it stops, until its final velocity becomes 0. Yeah, I have no information about time, so the best thing to do here is to use this equation where there is no time. V squared equals to V naught squared plus 2a delta x. Final velocity will be 0. Initial is that 40 meters per second, which I'll need to square. A is gravity and it's minus 9.8, and so we'll find this delta x. If you put it in your calculator, you should arrive at 81.6 meters. Very good. The next question is, how long is it in the air? How long? Well, the time that it takes to go up is the same time that it takes to come down. So I can compute how long it is in the air until it reaches this final velocity 0, and then multiply it by 2. So now the question is time, so I need to use an equation that has time. A good one is V equals to V naught plus 80. This is a good one because it's linear in time, so I don't need to solve a quadratic equation. So final is 0, initial is plus 40, acceleration is minus 9.8, and then I'll find this time. But remember, that is the how long it is in the air, the total time, which means it goes up and comes down. So I should multiply this number by 2. This should give us 8.16 seconds. The other possibility is, well, it goes up, reaches 0, and it comes back. And once it hits the ground, the velocity is now pointing down, and this velocity is going to be minus 40 meters per second. It's the same initial, same magnitude of the initial velocity. It just has opposite direction. So another way to find this time with a single equation at once is to say, well, I want to know how long it takes to come back to the ground and have this minus 40 meters per second, starting with plus 40 meters per second. And well, we need to use g, which is minus 9.8. From this equation here, I will get straight that value 8.16 seconds. So this is an alternative.